The next panel discussion actually consists of a couple of people. First, I would like to invite on the stage Todor Mladenov, CEO of Sofia Tech Park, our welcoming guest here. Then I would like to invite to the stage Yordan Georgiev from Helmholtz Dresden Research Center. And online will be our guests from Tyndall, Ireland. Giorgos, could you hear us?
I can hear you clearly. Good afternoon, everyone.
Thank you. And this will be our panel. And I would like to start. Giorgos, could you introduce Tyndall? What are your main activities? What is the structure? What do you do there? How do you do it?
Yeah, that's a fairly loaded question there, but I'll try to do it in a few sentences. First of all, let me introduce myself. I'm the head of EU programs at Tyndall, and I'm also responsible for one of our research programs, CMIES++, that is looking at the emerging materials and devices for future information processing. I'm also coordinator of two large-scale research infrastructure programs for access to European facilities to micro and nanoelectronics. The first one is called Ascent Plus, and the other is to be launched in January and is called InfraChip. At Tyndall itself, we have 600 people on site. We are Ireland's research center for information and communication technologies, actually for semiconductor technologies. We operate the only non-commercial clean room here in Ireland for open access. It's used by both our researchers, but also researchers across Ireland and also industrial users. We have research activities across the full value chain. We have actually a tagline where we say we go from atoms to systems. So we are looking at materials and development, integrating those materials into devices, device design and fabrication, and then integration of those into systems for applications in sectors like digital healthcare, energy, and then also ICT for agriculture, food, and the environment. Then I would say that's along the food value chain, but also across the innovation. So we are looking at the early stage research. So technology readiness levels at the proof of concept, and then also taking some of the emerging technologies to the next stage, up to perhaps technology readiness level 5 or 6 in certain areas of specialization. And particularly we do that in the area of photonics packaging and integration.
Okay, thank you. But later I will ask you what challenges do you feel about the higher tier levels, but this is the later question. Now let me allow to Dr. Georgiev to introduce Helmholtz Dresden Research Center.
Ало? Да. Най-напред да благодаря на организаторите за поканата да участвам в това мероприятие и се радвам, че сме в един панел с моя... Okay, we have to talk in English, sorry. First of all, thank you for the invitation, and I'm very happy to share the panel with my close ex-colleague Giorgos from Tyndall. Hi, Giorgos. Okay, now I am representing Helmholtz-Zentrum Dresden-Rossendorf, which is a large research center near Dresden with around 1,500 employees and 10 institutes. But to give you a bit larger perspective, so our center is a part of the Helmholtz Association. And Helmholtz Association is one of the 4 large research research institutions in Germany. So probably you've heard that in Germany there is a Max Planck Society, Fraunhofer Society, and Leibniz Society, and also our Helmholtz Association. And each of these institutions are specialized. So Max Planck Society is specialized in fundamental research. Fraunhofer Society is specialized in applied research, and Helmholtz Association is specialized in running large-scale facilities. And we're targeting grand challenges. So it is interesting that all the other societies, they're composed of institutes, and our association is composed of research centers. So this is by far the largest research institution in Germany, with around 45,000 employees. It runs 18 centers, and the annual budget, as I mentioned already, is 5.5 billion euro per year. So you can imagine this is really a huge institution. Our center in this association is it's one of the 2 centers in south, of 3 centers in East Germany. So traditionally it was in the GDR time a nuclear research center, but after the unification it was closed and founded again, and now we are not targeting, so we are not and actually the whole association not targeting specific sciences, let's say physics or mathematics or engineering or biology or whatever, but grand challenges. And in our center, we have 3 grand challenges that we are targeting in our research, and these are matter, health, and energy. And so our center is running 3 large-scale facilities. I told you that Helmholtz Association is about running large-scale facilities like accelerators, research satellites, research ships, stuff like this, really large-scale facilities. And our center is running 3 such facilities. One is the so-called ELBE. This is a source for high energy, or high energy source, so for high energy particles or high energy radiation. The other one is high magnetic field laboratory, which is holding actually the world record in the highest pulsed magnetic field, which is in the order of, now probably if it is already larger, in the order of 105, 106 Tesla. It is an enormous, enormously power field. And the third large-scale facility, which is run actually by the institute which I am representing, is the Ion Beam Center. And this Ion Beam Center is running facilities or facilities which can use science with a large range of energy, starting with few electron volts up to tens of mega electron volts. And these ions are used for modifying and analyzing matter. So very a large number of methods for modifying and studying matter at going down to nanoscale. So I particularly am running a facility for nanofabrication. So I'm representing, actually the center is not really focused on microelectronics, but I'm representing a department of nanoelectronics. We have a department of nanoelectronics which is running the clean room and the nanofabrication facility. So this is what I'm responsible there, and my research is in nanoelectronic devices based on group 4 nanowires, silicon, germanium, and stuff like this.
Yeah, thank you for the sample that you provided us. Actually, just for the audience, Yordan just bring a junctionless transistor here because we were working together on a project, and we are going to to characterize it and try to do some testing facilities. And Todor, thank you for being so welcoming guest here. Could you describe Sofia Tech Park facility and give more background information? What it is, how it works, what are the activities?
Thank you very much for the kind invitation to attend this forum, and particularly to be on this panel. Probably I'm one of the few people that does not come from the industry, does not come from the microelectronic field, let's say, but my position is such that I actually need to be in a team that is its main goal is to develop the ecosystem, to develop the environment, to develop the facilities, the infrastructure, and of course to attract interest and clients to all the services we provide actually in Sofia Tech Park. Well, I do believe that Sofia Tech Park should be quite well known already, but I'll do a very brief, let's say, presentation to what we do actually today. So we, as a design, as a concept, we are developed as a science and technology park, which means that we have invested our, let's say, our resources, our focuses and our, let's say, expectations in two general fields. One is the R&D, and the other is the applied research that is related very much to the industry, and more and something else that is also very important. Our focus is also very well aligned to the development of the entrepreneurial spirit or the entrepreneurial skills of our, let's say, of our society. So in this case, we have invested, and we are operating together with some of the leading and probably most classy university in Sofia in Bulgaria, the Technical University of Sofia and the Sofia University, the Medical University, some of the institutes of the Bulgarian Academy of Sciences. Really, I would say very modern, very sophisticated R&D facility. We provide services in 11 different labs. Some of them are related to the biotech industry, but the rest of those 11 focused and provide services in the field of the mechatronics, microelectronics. I mean, it was mentioned a few times in the morning session. We do services in the cybersecurity, HPC, which stands for high performance computing, Internet of Things, technology for the Internet of Things, and all those 11 labs, they're designed in a way to work closely with the industry. Nobody is so much excited and believes that it will happen overnight. This is a process. We strictly and very carefully follow and we are taking a look at what the advanced countries, the advanced economies have done in the last 30 years. So we see that this is a process. For example, the researchers, the academia, the people from academia, they have certain profile, they have certain mentality, they are very talented, they are very skillful, but sometimes they need more of a cooperation with the industries. The industry, for example, they are more demanding, they need everything to happen very fast, to structure projects, to implement those projects very quickly, which is nice, but it takes time in order to get those two, let's say, communities together and to make them understand how the processes from both sides actually work. When this is known, when this is kind of nurtured, then the results come very fast. We had a few examples. This morning. It takes time. It takes patience. It takes a lot of resources to be invested. It takes also a lot of knowledge to be developed, because we all see nowadays it is the great. Now we are operating in a global economy, in a very competitive environment. So everybody, different regions from the world, different countries, everybody is focused and invests a lot of money and a lot of resources into their economy to be competitive. That's what our country have done also. So especially in the last 3 to 4 years, we have invested a lot in facilities. It is out there. So, the main focus, what comes next, is to invest more in people. So, invest more in skills, in knowledge, in people, in collaborations. So, our facility here in Sofia Tech Park I think it's well prepared. It's well prepared. We have the facilities. We have the basic stuff, the basic teams. So what we need is to have the resources, to receive the resources, and actually the tasks, either from the industry or from the government, in order to invest in certain types of technologies, in certain types of solutions that can hopefully someday get on the market. So in conclusions for my introduction, so we do a lot of research. On the other side, we are also very promoting and delivering a lot of services for small and micro companies, different incubation, acceleration services. I just want to mention that we opened our new brand of incubation services just 3 weeks ago. It's on the market. We have a quite significant interest. More than 50 companies showed their interest. 12 of those companies are already on board, so they will join the incubation company, the incubation program. And of course, something that is also very viable and very important for the development of the whole ecosystem and the whole skill and talents around is we do a lot of events. This type of event is one of the many that we every day actually implement here on the campus of Sofia Tech Park.
Okay, thank you, Todor, for the great introduction. I just would like to give the word for Marius Purcar from University of Cluj-Napoca. He is online. He wasn't present during the start of the panel. Let me see if we have a contact with him. Marius?
Yeah, hi. It's Marius Niag, not Marius Purcar.
Sorry.
Marius Purcar is a colleague of mine, and he couldn't attend today. But I received the invitation, so I attend with some delay. Sorry.
Could you briefly introduce University of Cluj-Napoca and the facilities related to the microelectronics and the services related to the microelectronics?
Sure. So, Technical University of Cluj-Napoca is one of the main technical universities in Romania. Is ranked on the top tier. There are, in fact, 4 technical universities which are nominated in the Romanian microelectronics section of the National Plan for Recovery and Resilience. So it's on the par with the Polytechnica University in Bucharest. That's the largest in the country. Then it's our university, the Technical University in Iași, and the Polytechnica University in Timișoara. These are the 4 universities which, as I said, were mentioned were assigned in the national plan to foster centers of excellences in microelectronics. So what we do in Cluj, in the field of microelectronics, it's mainly analog IC design with the perspective to expand into digital as well. So the situation in Cluj is kind of particular, different from, say, Bucharest, in the sense that in Cluj there is a lot of software going on. There are a lot of software companies, and we need basically to compete for students, for the students' attention or the students' interest with software. So that meant we developed a bit later and a bit less at a smaller pace than our colleagues in Bucharest in particular, but also Iași. So what we do in as I said, analog IC design, in particular for power management, and very focused on cooperation with industry. The main IC design company in Romania is Infineon Romania, obviously, but there are also a few other big companies are present, Microchip, On Semiconductor, and so we try to cooperate with these companies in particular. So we have just under 200 students per year attending electronics courses. There are 3 specialities. One is applied electronics, the other is telecoms, and a third will be microelectronics. So it's about 30 to 40 students in microelectronics that will be specialized in microelectronics. So in going forward, what we do, first of all, is the national plan I mentioned, so to try to contribute to development of centers of excellence. Next, there is a part of it is also an IPCEI project, if you know the special, the important project, European projects of, what's the acronym complete? You know that scheme whereby a particular field.
You're talking about the IPCEI projects?
IPCEI, yes.
Important IPCEI, projects of Europe, common European interests in microelectronics.
So, such a project is ongoing. Well, it's starting. It's supposed to start this until the end of this year. So there's quite a bit of funds there allocated to 3 to 4 companies. so we are now in the stage where some administrative procedures are to finish off. Our university is going to play a part in projects led by Continental. Continental is the largest employer in Romania in electronics, and of course is not IC design, but is as you know systems and modules and so on. Also with Bosch. Bosch will be the largest company in Cluj, in the Cluj area. They have a plant and also R&D center. That's mainly in embedded software. Then the third will be NXP. NXP does a lot of software for their chips in Romania, so I don't know so much about them. And also Analog Devices. Analog Devices has a pretty large team in Cluj. They do mainly modules, system development, software, and so on, and they are expanding into digital IC design. So that would be basically the short-term focus for us.
Thank you, Marius. Thank you for a great introduction. Later, I have questions on the topics that you've described, but just let me go back to Giorgos. Giorgos?
Yes.
My question is, you said that you are focusing Tyndall actually is focused more on the high tier levels, and my question is, what are the challenges and what are the possibilities in going for these high tier levels of different innovations, not only for microelectronics, but and what is how you do the technology transfer for that after that?
Yeah, maybe I'll just elaborate on this a little bit, right? So as Ireland's research center for semiconductor technologies, we have been established in a joint venture between University College Cork and the government to be more industry facing. And it is part of our remit really to take, not only to contribute into new R&D and emerging technologies in the lab, but translate those or at least put in place the conditions to be able to translate the most promising ones into manufacturable products and into actual applications. So there are many challenges in doing that. You can't do it for all the research lines and that we currently have in progress. So you have to pick up your bets and prioritize and specialize in what seems to be the technology to be translated, and that very much depends on the industry pool. So we are in constant interactions with our over 200 industry clients to identify what could be the industry pool for the technologies that we are developing in the lab. And that is happening several times also when we have, in particular with our researchers in residence program, where we have industry researchers in residence program, where we have industry co-located here at Tyndall that work together with our research teams. And in particularly around, for example, production tools, or in, for example, the photonics packaging that I mentioned, or microtransfer printing, which is one of the promising technologies for heterogeneous integration of chiplets. So the challenges is really to first to be on the as I mentioned, to be alert about the industry pool, and identify early which technologies can be translated to higher technology readiness levels. And the opportunities is that you can actually get your research out there into the product, and this we have managed to do. We are doing it essentially with several transfer models, licensing or spin-outs. So several of our spin-outs have been able to scale up and eventually acquired by the likes of Meta, the likes of onsemi, and in other cases, we have worked directly with original equipment manufacturers to upscale the technology in their manufacturing lines, so that it is in their product, and that is rewarding in terms of visibility at the national and international level, but also, as you can imagine, has significant monetary value also for being able to sustain our innovation pipeline.
Okay, thank you. Thank you for the great answer. And now I would like to ask Yordan, you describe such a big institution, really amazing one, really specialized in different specialized fields. And my question is, how do you collaborate? How do you find people to run those research scale infrastructure? How do you collaborate with academia? And how do you attract talent? Because we are talking about talent all morning.
Oh, that's a good question, and that is not very easy, by the way. Good point there in Dresden is that we have very large technical university, probably you've heard Technical University of Dresden, which is one of the 11 excellent universities in Germany. So this is a good source of talent, but still, I mean, it is really challenging for research institutions to get to attract young people to work in research, especially in a country like Germany, where until recently, the industry was working very well, so it was booming. And it was really attracting all young people graduating universities. And therefore, we turn our interest, our focus also to people from Asia, which is a large source of talent. So a lot of our PhD students, postdocs, so other colleagues, they're coming from Asian countries like India, China, Iran, Pakistan also, the largest sources. But yeah, we have to really compete with the powerful German industry for young talent. But another thing that I want to point out about when we talk about infrastructure, and so Germany is a large country with a very strong economy, at least still with very strong economy, and it can invest a lot of money, and it is investing a lot of money in research infrastructure. So in Bulgaria, we are not such a large country, and the economy is not so powerful. Therefore, we have to really invest, smartly invest in infrastructure. So really in infrastructure which is definitely needed, which is fitting our ecosystem or our environment here, so that it is really benefiting the stakeholders. And what is also very important, and what is the case in Germany, in Ireland, so this infrastructure has to be widely open for mutual use. So there, at least, so I've been working here in research for a long time, and there was earlier a tendency of kind of protecting or guarding the available infrastructure only for the particular institution, and this is not the working model. So infrastructure is funded by public money, and it should be available, openly available for the public. And this is the case also in our research center or in the facility that I'm running. So we have not only our local users, we have users, global users from Europe and worldwide users. So this is I think this is the working model also for research infrastructure in Bulgaria.
Actually, thank you. You really made a point, because at least my personal opinion that in Bulgaria, across the fields, I think that we have sometimes competing capabilities in a couple of institutions, and that's really a great point, and should be aligned and more open for to be able to use by public, because this is the working model. And actually, as I'm also part of Sofia Tech Park, and Todor will tell us a little bit more, that we try to be open to the all industry interests and all research interests, and maybe Todor, you could tell us about more how the people could connect and use the equipment that is here, research equipment that's here.
Yes, we are smoothly coming into the details. This is really very important. I mean, so as we can see, we have the infrastructure, we have the facilities, we have very nice, appropriate equipment, which is kind of allocated in different institutions. So the point is how to be actually open, well recognized, well known, and then smoothly provided to be used, both by, let's say, by applied researchers, but most importantly to be used by the industry. What we have developed so far, probably we have not gone too far in this field, is to actually promote everything we have as important facilities, important equipment on our websites once. Secondly, we have been doing constantly open days to this infrastructure. So we have been promoting this type of infrastructure, and actually the conditions to be used to the general public, and also to the industries. How we do it with the industry? We target the industry. So we do a list of let's say of targeted companies that we recognize in here on the national market. So we call them, we talk to them, we invite them, we do tours. We meet them with our researchers. You personally have been many times part of this type of tours and negotiations with the industries. So we do everything we know and everything we can in order to promote the use of that infrastructure. By the way, especially in the beginning, in the first years of operation of Sofia Tech Park, I remember some of the breakpoints while we were promoting those options. Most of the industry was expecting this to be free, very easily, accessible, which is not the case. I mean, this is very expensive, very hard to get infrastructure, very difficult to maintain, and then to reinvest. Sometimes that equipment is also very quickly running out of date. What we were, telling and what we were promoting is that in order to be open, this should be accordingly, covered the cost of using this infrastructure. So we had a, experience and few years of doing this, and now we are constantly, I think we have good progress, and we are constantly, year by year, increasing the turnover of our joint projects and our services provided to the industry. But it is a timely process.
Yeah, I know it's quite a hard, especially with this kind of a specialized infrastructure where you have to find a concrete person and concrete company that is using it. And just one follow-up question. You said that it's really hard to maintain it. I personally know that well. How do you secure? What is the main funding scheme to ensure that this equipment is operational?
If I'm understanding correctly the question, we are doing our best in order to first to ensure public funding for the upgrade of such an infrastructure. So we have been very active in the last few years. We have done our first, breakthroughs, attending or actually participating in high-scale European projects, for example, in Horizon 2020. Now we are almost ready to apply and to launch a project within the new operational program for research and innovations. I mean, the funding is just around the corner, probably in the beginning of next year. We might be able to use those funding. And next, we are also reinvesting some of the income that we generate in this campus from different type of activities into upgrading our let's say our equipment. And what is most important is to extend the capacity and the number of people that are actually operating this equipment, which is, I think, this is really essential for our let's say efficiency. So step by step, we actually hit the number of more than 60 researchers that are employed here in Sofia Tech Park recently.
Okay, thank you. Marius, I would just like to ask one closing questions to you.
Yes, please go ahead.
Just curious, all other gentlemen here in the panel are representative research infrastructures. What kind of access, apart of the university, what kind of other research infrastructures you have in Romania? And are you able to go there to do your research, and what are the conditions?
Right. So, first of all, research within universities are organized in what's called research groups. So we have the kind of standard academic structure on administrative and teaching, with faculties and departments. But for research, there are research groups. For example, in my department, there are 5 research groups. Actually, can I share the screen? Let's see if I can share the screen, maybe. Share content. Just give me a second. Yeah, let's see if you see it here. I have a short presentation of my research group. So my research group is called Digital Enhanced RF and Analog IC, right? So you see, can you see my screen?
Yes.
Okay. So it's 8 staff members, 2 postdoc researcher, PhD students, undergraduate and master students, right? And these are our competencies. I won't go into too much detail on this, but just to answer your question. So first of all, we have our own research labs. We have a farm of simulation servers. Now, access to tools. First of all, we are members of the Cadence Academic Network pretty much since it started, and also Europractice. So that's the main source of tools and PDKs. Now we also have access to other labs within the university, for example, an EMC lab with anechoic enclosure and other general purpose electronics labs. Now, outside the university, we have access through various cooperation arrangements with research institutes. In Romania, the system is based on the so-called, well, it's really like national level research institutes. There are a number of them. Probably the best known in our field is IMT Bucharest. So this is the National R&D Institute for Microelectronics. It's located in Bucharest. It was founded, I think, almost 25 years ago, I think. So and they have clean rooms. They can produce small scale sensors and so on. But at the end of the day, the main thing we do is, as I said, cooperation with industry, right? So, for example, you have here an example of. Let me see if I have. Okay, it's probably not the best slide, but still, it's a slide that allows me to point out the fact that this is a chip that we design within an EU-funded project in cooperation with Infineon Technologies. So basically, they ask us to explore the possibility of developing an LDO with less than 1 microamp quiescent current and still able to have a good response to fast low transients. So we design it in their technology. They help us with layout and then integration. We designed the characterization board, Infineon manufactured it. Then we helped with the characterization, but the main test and characterization, including temperature, was done on their side. So in the last 5-6 years, this was the best arrangement for us. So I'm talking again about analog IC design. So in terms of infrastructure, what we need is access to tools, access to PDKs, and access then to silicon integration. And the most effective way we found so far was through this kind of cooperation with industry. It's not the only way. For example, here, what you see here, this is a test chip designed 12 years ago or more than 10 years ago through Europractice. So this was cooperation with within 3 universities. You have here, you see, it's like the map of Romania. So Cluj is somewhere in the northwest. Bucharest is somewhere in south, east, and Iași is some in the east of the country. And this is reproduced here in a sense. So this northwest corner are blocks we designed in Cluj. The east side was designed in Iași, and the south in Bucharest. So this is an example of a test chip.
Marius, I see that on the southeast you have a BG. Is it designed in Bulgaria?
Well, no, but in fact we do have. Let's see if I have a slide like that. We do have a bit of cooperation with Bulgarian company Melexis in Sofia. Again, a few years ago, we had a kind of R&D project. They asked us to let me see if I have it. I should have it somewhere. To develop, to design the analog interface for automotive sensor. And it was the same situation, right? So we designed there were effectively 3 blocks. So low noise amplifier, a filter, and some interface. So we designed it in their
Marius,
and everything.
I would ask you for concluding words because we are running out of time.
So my point really is, to answer your question, cooperation with industry in analog IC design is key. Digital design, I think, goes the same way. In more, let's say, in other applications, I suppose people need more access to infrastructure. But the key challenge we are facing is what was discussed by other speakers before, and that is human resources, right? And I just want to make a point about how we try to increase the let's say attractiveness of electronics, IC design, but electronics in general. So this is
Marius, may I ask you just because other speakers are coming in?
Yeah, sure. Yeah. Okay, yeah, I'll stop now, and maybe we can continue.
Yeah, we'll continue this discussion further for sure.
Sure. Okay.
Yeah. Thank you. Thank you for the Todor, Giorgos. Thank you for Yordan. Thank you for your participation, and I hope you enjoyed it. And now we are going to the next panel.
Okay.